Here we're going to talk about different interest formulas that we can use now that we know a little bit about exponential functions. And we're going to talk about solving some exponential equations. So first, let's talk about the compound interest formula. The compound interest formula is A equal to P times 1 plus R over N raised to the NT. So let's talk about these different parts. A is the amount of money accumulated after T years, including interest. So the amount of money accumulated after T years, including interest. P is the principal or initial amount. That you deposit or borrow. R is the annual percentage rate. Which sometimes you will refer to as an APR of interest. And with that, we have to remember to divide by 0, or 100. N is the number of times the interest is compounded or calculated per year. So the number of times interest is compounded, calculated per year. And finally, T is the number of years the amount is deposited or borrowed. So now we're going to use this formula in a contextual situation. So for example, an amount of 1,500 is deposited, so that tells me that that is my principal amount in a bank that is paying an annual interest rate of 4.3%. Now remember, 4.3, we need to divide it by 100 to get 0.043. That is our rate. Compounded quarterly. Quarterly tells us that that is 4 times. So 4 times, that is our N. What is the balance? If we want to know the balance, that's A after 6 years, so T. So use our formula, A equals P times 1 plus R over N raised to the NT. So if I want the amount, I need to do the initial 1,500 times 1 plus the rate 0.043 over 4 times, that is compounded, and then raised to the power of 4 times 6. So here is where I will switch over to my calculator to get the answer here. So take your calculator. You're going to enter in 1,500 times 1 plus 0.043 divided by 4 times compounded, raised to the 24th power, or 4 times 6, whichever you choose to do. And I get an amount of $1,938.84. Now, let's talk about when we're doing continuous compounding. Continuously compounding is a different formula. That is A equals the principal initial amount times E to the RT. All the parts of this formula are the same as above. The only thing that changes is that that constant E is in this formula. And that happens whenever we have a continuous compounded. So let's do an example where it's continuously compounded. An amount of $1,500 is deposited, so that is our principal, in a bank paying an annual interest of 4.3%, again, 0.043 after dividing by 100. Continuously. Anytime you see that word, think E. The balance, I don't know it, so I'm going to find that. After 6 years, T. So P equals A equals P-E-R-T. You can think of it as PERT. So annual amount equals 1,500 E raised to the 0.043 times 6. Now in your calculator, we need to figure out where that E is, rather than putting in 2.7, because that will skew your answer. In the graphing calculator, you can do two ways. You can hit second, and then the division sign, or you can hit second, and then the button that says LN. That's a few buttons down from second. In your scientific calculator, you hit second, and then 2 buttons down is ln. There is no actual just E on the scientific calculator. So let's go ahead and go through it on a graphing calculator here. So if I do second, or I want to put in 1,500 first. Second, E is on the division sign. It's right above the division sign. Now, you could also go, again, like I said, second and hit ln, and it'll just give you E raised to a power. So I'm going to raise it to the power myself. 0.043 times 6. And I get the answer of 1,941.51 after rounding. So the question to think about after this video is, would you rather compound continuously, quarterly, or some other way? So kind of think about these two values and maybe play around with different compounds. So maybe monthly or annually or something else.